Guys, I am going to work on the independent t-test in SPSS, and we are going to look at if there is a statistically significant difference in the hours studied based on the children variable. So the first thing I need to go is I kind of need to go into children and see what is that. So if I'm in children and I look at my values, that's yes, they have them, or no, they don't. So that means I have two groups. There are two values, which means that there are two groups so that I can proceed with my independent variable. So my assumption is I need two groups, I have two groups. Before I can run my t-test, I have to check for outliers and I have to do Shapiro-Wilk. So I'm going to go into that Explore menu and I am going to keep hours of per study here. And then I am going to add my grouping variable in here because that is going to work on looking at a different type of analysis. So I said I was going to group with children, and for some reason it is in slightly different of a setup, which makes it harder to find where children went. And so it does subject have children. Then I'm going to go into plots. I want to have my normality plot selected. I want to factor levels together. And I want to have spread versus level with Levine's test set at none. Then I'm going to click OK. And I'm going to go down to here is my test of normality. And then I have my box and whisker group here that shows me there are no outliers. So because there are no dots above or below the whiskers, I meet the checkpoint or the assumption that there are no outliers. So I'm going to take that box and whisker, I'm going to drop it in here, and then I'm going to say that there were no outliers identified. So that's going to meet that component of that. Then for the normality, that is going to be the Shapiro-Wilk test. If my p-value is greater than 0.05, it does not deviate from the normality. But if it's less than 0.05, it does. So let's go back up to our table here for our test of normality. And so if I'm looking at the normal distribution, I'm going to check it for both groups. So I'm going to look at the Shapiro-Wilk significance of 0.61 is greater than 0.05, so that this one, if I'm here, it does not significantly deviate from normality, meaning that it is a normal distribution. However, for the group of hours of study, this significance value of 0.03 is less than 0.05, so if I'm looking at hours of study per week, this does violate the assumption. However, it is a large sample size. I have a lot of data points in this example set, so I'm going to leave a disclaimer that it is normally distributed when I look at the hours studied and the people who have children. But the people who don't have children, it does not have a normal distribution. And I'm going to make sure that I have my table right here. Now remember the next one, the homogeneity of variance, you can't actually check that until you do the actual t-test. So I'm going to scroll down to how do I do my t-test, and then I will come back to that assumption. So I'm going to go into Analyze, Compare Means, and I'm going to go into my Independent Samples t-test. My hours studied per week is a continuous variable, so it goes in here. And then my children question will go into the grouping variable. So whatever is the categorical data that you're using in that second assumption, it's going to go into that grouping variable. Next, I need to define my groups. A lot of times students will actually get stuck here and they won't be able to advance. So in here, I'm just looking for what were the numbers that we used. And if you're not sure about the numbers that you used, if you go over to variable view and we go into children, I use the value of 0 and a value of 1. And you'll notice that that's very different from what SPSS defaulted to just now. So my groups would be a 0 and a 1 because those are the labels that I used. So once I have my expected groups, I'm going to go in here and I'm going to go back to continue, and you should see that that populates. So see how it says children 0, 1. That's how I know I did it correctly. Then I'm going to click options, and I want to make sure that I see a 95% certainty. And it is set to 95, so I'm going to run my test. Remember, this is the group statistics table, so this is just telling me for those who don't have children, they study on average 11.38 hours. For those that do have children, they study 19.5 hours. That's a lot different in time. So that's but I don't know if that's significant until I can come down here and I can look at Levine's, and I know what I am doing once I look at Levine's. So I'm going to look at these two columns are my Levine's. My sigma is 0.01, so I'm going to go back to my assumption. If my sigma is greater than 0.05, it is equal variance. If it is less than 0.05, the variances are not equal. In this case, it is less than 0.05, so the variances are not equal, which means you will pull from the second row of the table for your sigma two-tailed value that you are looking at. So I'm looking at sigma two-tailed right here. I've got my mean difference, I've got my standard error, and I've got my confidence interval. All of those are found down here. My t-value is in the second row. My degrees of freedom is in the second row because Levine's came back as not equal variances. And that is how you run your t-test. You will also note that I have a Cohen's d-value. I want to look at the point estimate, and I would be able to utilize that to get to the effect size. So that is utilizing SPSS to conduct an independent samples t-test.